I'm Alex, and I work in Visma. And today I'm going to talk about why we started to measure software delivery and operational performance, how we do it, and some initial results. But first, it's important for you to know the context of Visma. It might not be the same as yours, and what I'm going to show you later will not make sense without this. So we're a cloud software company. We make lots of different cloud software. HRM systems, payroll systems, school systems, health systems, many other things. But we are a company of more than 200 other companies. And these companies have a lot of autonomy. So there are some things we're a bit strict on, like financials and security. But in terms of technology choices, each Visma company is free to choose the technology that makes sense to them. Now, last time I was here, I talked about the Visma Cloud delivery model. This is our recommended way of developing, delivering, and operating cloud software in Visma. But any team, any company in Visma can choose whether they want to sign up and be part of this or not. And it's been a kind of a transformation program that we have used to help teams and companies move from the old way of working to the new way of working, right? From development and operations in silos to autonomous cross-functional teams with end-to-end responsibility, from monthly to daily deployments, and from traditional infrastructure to automated use of public cloud platforms, containers and serverless and all that. So today in Visma, there's about 80 teams that are working according to this model. We started it in 2015, and it's something that we are still developing and implementing across the company. But then in 2018, the Accelerate book came out, and I assume the majority of the audience here probably have read this book by now. When it came out, it was very helpful for us. First of all, because it gave us some confidence that what we were doing with the Visma Cloud delivery model was kind of pretty aligned with what the recommendations and the conclusions of this book was. And it was very helpful to use in internal communication as well. You know, we're not just making things up. Continuous delivery and DevOps and public cloud, it's shown also. This is another example that shows it is very valuable. And just in case anyone have not read this book, the very quick summary is that it is researched based on global surveys that was done over 5-6 years. They asked people, how do you work with software development in your organization, and how well is your organization performing? And the idea was to try to see what kind of practices were predictive of high organizational performance. And they found 4 or 5 metrics that were the most strongly predictive of organizational performance, and they called this software delivery and operational performance. And they conclude, I'm not sure if that was in the original book or if it was in the State of DevOps Report 2019, but this quote that the elite performers in terms of SDOP, the top 20% or so, were twice as likely to meet or exceed their organizational goals compared to the rest. So if you're a private company, then you probably have commercial goals. So of course, this conclusion is then very interesting. How can we achieve this? Then 2 years later, McKinsey released this report on Developer Velocity Index, which is kind of a similar story. They also studied companies over several years. And they created this construct that they call Developer Velocity Index, consisting of 46 different metrics about how does this organization work with software development, product development. And what did they find? They found that the top 25% of companies in terms of Developer Velocity Index, they grew 5 times faster than the bottom 50%. So also another significant finding and very useful in our internal communication because we were pushing for these practices, right? So the conclusion of both of these in some way is that they show that engineering performance drives commercial performance. Okay, great. We thought that was the case, and we have more support for that claim now. But then we were wondering, okay, do we actually measure engineering performance today? And while some individual teams or companies might do that, we didn't do that from a centralized point of view. So we decided to adopt the software delivery and operational performance metrics. Like, obviously, we are interested in these metrics anyway, and if they are predictive of organizational performance, that's just another reason to care about them. So we decided to start to measure this. Many teams and companies in Visma cared about these metrics from before, but we didn't have any centralized way of looking at it across the company. So what I'm going to do now is to go through these metrics one by one and maybe comment on how we have interpreted them and how we are defining them in case you want to do the same, because some of them have there's some trickiness to some of them. At least that's what we found. So if we start with lead time. In the Accelerate book and in the State of DevOps reports, it's usually called lead time for changes. The problem is that people have very different ideas of what lead time actually means. So in Visma, we consistently call this metric delivery lead time to kind of remind people that this is the time it takes to deliver a change to production. It does not include design, it does not include implementation. So we just look at when a change was successfully deployed to production, and we subtract the time it was actually implemented. The main value of this metric, as I see it, is to identify any bottlenecks that you might have in the delivery process itself. Obviously, it will not catch anything in the implementation process. But you might ask, should you include testing in this? And if we look at the purpose of the metric, it gets easier to answer this, right? So if we're talking about implementation of automated tests, unit tests, then it's obvious, yes, no, that's not part of delivery lead time, that's implementation. But if we're talking about executing automated tests as part of the delivery pipeline, or if we are deploying to a test environment and running manual tests before we deploy to production, then obviously, yes, those are bottlenecks that are slowing down our delivery. What about code review? For me, this is a bit of a gray area, but I would tend to want to include it. The reason is, if you have developers asking for a code review and they are not picked up, well, that slows down your delivery. So if you can, I would include it. Then we have deployment frequency. This is the easiest one. We just count the number of deployments to production, and we measure some kind of throughput in the team or the organization we're talking about. But more importantly, we're getting an idea of the cost of making changes to the system. And we'll talk more about that in a second. Change failure rate is a tricky one. The definition used in the books and the reports is the percentage of deployments that causes a failure in production. No. What? Oh, thank God. Okay, that scared me. Yeah, so why do we care about change failure rate? Well, when we have failures, that often causes double work, and it can cause reliability problems, right? The quality of service that we're providing to our users. The problem, though, is this definition implies that you need to causally link failures in production to individual deployments. If you make a deployment and then a failure manifests an hour, 3 hours, 3 days later, you need to link it back to a deployment. And that seems quite impractical. So what we do in Visma is to say the change failure rate is the rate at which the system fails when we try to change it. So then what we need is to figure out how many failures have we had in any period, and how many times have we tried to apply a change. So we count the number of failed deployments. That's one type of failure. We count the number of incidents. That's another type of failure. And we divide that by the number of times we have tried to automatically apply changes, meaning a deployment. And we add any times we have tried to manually apply any changes, if any. So that's how we calculate the change failure rate. And it's a decent approximation. Time to restore, an old and good one, the time it takes to recover from unavailability. And we'll get to a second, what that is and how we define it. We take, whenever the system went down, when it comes up again, and we take the difference. We care about this because it's some measurement of how prepared we are for operational issues, and we can identify or capture any bottlenecks that we have in the recovery process itself. Then finally, we have availability, and there are different ways of measuring this. What we use for these purposes, for software delivery and operational performance, is to look at the percentage of time the system is available. So for any reporting period, we just subtract the time any system was unavailable and multiply by 100 to get the percentage. And of course, this is one expression of the quality of service that we have provided to users of that system. But of course, the question is, how do we determine whether a system is available or not? And we outsource that decision to each team or company. So if I have an application and the profile pictures don't load, if my system is an online bank and I cannot see the profile picture of my financial advisor as I'm chatting to them, we wouldn't say that the bank is unavailable. If everything kind of works, I can do what I need to do. If we were talking about Tinder, it might be a different story. And the same way we give this decision to the teams, we say, if you have significant negative customer impact, then you should count or define the system as unavailable. So how do we get teams, data from the teams across the 200 companies into one central place so we can report on it? We ask teams to submit data to Jira, of all things. Jira is one of the technologies that are pretty widely adopted in Visma. So teams will both automatically and manually submit data to Jira. Then we replicate that to another database where we run our reporting against. And right now we're using Tableau for that. But what are we asking our teams to report and how? Well, we're asking the teams that participate in this to put a script in their deployment pipeline so that every time they deploy something to production, they create a Jira issue automatically using the Jira API. And this is the kind of simplified information that they include in that issue. So they say, I'm this service or product. The deployment was a success or a failure. This is how many changes were part of this specific deployment. And they calculate the total delivery lead time for all of those changes. Then once in a while, it's very rare, but if a team applies a manual change, so not through the delivery pipeline, then we ask teams to register an SDOP change issue in Jira. And if there is any unavailability associated with that manual change, then they say when the start time was, when the end time was. And finally, we ask teams to register high impact incidents. So that's when there has been significant negative customer impact for their users, regardless of reason. And they register when that started and when it ended. And this is then how these different issues inform the different metrics that we then calculate centrally. Then we build reports on top of that. So we have reports in Tableau, and this is available to everyone, all employees in Visma, transparently. So any team can track their own performance over time, or they can benchmark themselves against other Visma teams or companies. This is the deployment frequency report. This is the time to restore report. You get the idea. We have this for the 5 metrics that we care about. And some teams even connect to the data source and create their own reports, which is good. Now, we have a lot more data in Visma than just software delivery and operational performance. We know a lot about how engaged our employees are. We know a lot about how users are enjoying or not enjoying our products. We know how many teams and companies work, what technologies they use. We have a lot of financial data, et cetera, et cetera. So we have relatively recently set up a project that tries to combine all of these data sets that we have available across Visma, and then do analysis on that and try to extract some insights. One central question is the same as it was for the Accelerate researchers and for McKinsey. Can we say something about what actually drives commercial performance? And software delivery and operational performance is one part of the bigger picture in that case. So we can, for instance, try to combine financial data and software delivery and operational performance. The only difficulty for us so far is that deployment frequency is something that we have cared about and measured from a central point of view for a long time. For lead time, for instance, delivery lead time, that's not something that we have measured for many years. Right? That started relatively recently, so we don't have excellent data on that yet. So the main result I'm going to share is about deployment frequency. And what we see when we sort our products, the Visma products, on deployment frequency, is that the products that are deployed frequently grow a lot faster than those that are not. So the top 25% of Visma products in terms of deployment frequency are growing more than 4 times faster than the bottom 25%. And roughly speaking, we can say that the top 25% of products, that those are those that are deployed on a daily basis, while the bottom 25% are those who are deployed once a month. Now, if this looks a little bit familiar, it's because it is pretty similar to the results from the McKinsey study, where they looked at developer velocity index. Remember, this was 46 different metrics, and they found that the top 25% of companies grew 5 times faster than the bottom 50%. And I think it's interesting, it's quite impressive that deployment frequency it's a very powerful metric, right? It captures a lot about the performance of an organization, which you might not expect kind of superficially. So if you're wondering how can a technical and fairly superficial metric like deployment frequency capture so much about the performance of an organization, I think we can try to answer that. First of all, obviously an organization that can adjust and get feedback hundreds of times during a year instead of 12 times during a year is likely to perform better, right? This is an innovation capability. If you have a higher deployment frequency, you're probably making smaller changes, lower risk, better reliability, better quality in the products. But the most important one, I think, is that in order to sustain a high deployment frequency over time, it must be cheap and easy to make improvements to the products. It must be frictionless, or as close to frictionless as you can get. So that means there are a lot of things that can stand in the way for that, right? And that's why I think this can capture so much about an organization. So if you're working in an old-fashioned way where you're deploying on a schedule once a month or every Tuesday or whatever, that's going to hold you back in terms of performing according to this metric, right? So then it's capturing something about the culture or the methodology or whatever it is. If you have maintenance windows with downtime, obviously you're not going to deploy frequently. That's going to show up in this metric. If you're wasting time on manual testing or manual deployment processes, that's going to show up. If you're spending time on working around old technology, if you don't have a scalable organization, if you're lacking key competence, if you have terrible culture, all of those things can show up in this metric. And that, I think, is the explanation for why it says a lot about an organization, this simple metric. Another interesting finding was that the Visma products where we don't have data about deployment frequency, those are the products that are growing the slowest. So of course we're using this, building awareness around this in Visma to get more people to measure this. But of course there are multiple reasons why this relationship exists. But if you don't measure it, you don't maybe have the awareness, or it's harder to improve. So one final thing about public cloud. So public cloud is not part of the software delivery and operational performance construct per se, but both in the Accelerate book and in the State of DevOps report, they talk a lot about how the NIST cloud characteristics support you in achieving higher software delivery and operational performance. And that's definitely true in Visma as well. For us, using public cloud platforms has been a critical success factor. And we see that in many different ways. So for instance, we see that the products that we have hosted in public cloud are more innovative than those that are not. And we see that the Visma products that are hosted in public cloud are more liked by the users than those who are not. Of course, this is also a function of the fact that products that are hosted in public cloud are more likely to be newer and have more investment. But even when we control for those factors, these relationships are still true. So we have barely gotten started with this research. As you see, engineering performance is one of 4 areas that we are particularly excited and interested in. We think all of these 4 are critical for commercial performance. And software delivery and operational performance is, of course, only one part of the engineering performance again, right? We're also interested in security, and we're interested in technical debt, many other things. And the next year or 2 is going to be pretty exciting because now we've gotten this project kind of just up and running. But even now, the results are pretty cool. If you want to know more about how we work in Visma, you can go to YouTube, search for Visma and DevOps, and you'll find multiple talks. If you're curious how we are organized, there's an article on the Team Topologies website as well, which you can check out. If you have any comments or questions after today, you feel free to connect with me on LinkedIn as well. With that, thank you.